What do you think, which parts are stronger? Printed with 3 walls and 0.4mm layer width, or printed with 2 walls and 0.6mm layer width? Hello, welcome to my tech farm. A few weeks ago I tested the strength of the spiral mode printing, varying different nozzle diameters and line width. And one of the conclusions was if the printed line is more squeezed, in that case the layer will bond better to each other and we will have better layer adhesion. And in this video I want to test exactly this with the regular printing, so I want to see if using 3 lines with 0.4mm width are similar or how they compare to 2 lines with the 0.6mm line width. And in every case I will use 0.4mm nozzle with 0.2mm layer height. Let me show you the test objects. These printed in vertical position are more important, so that's why we have 3 from each. This is for 3-point bending test, and this is for the tensile test, and from this I will have a horizontal version too. Hook test and the C creep test the deformation maybe during one day. And I want to measure the effect of the walls, so that's why I set the infill to 0%, and this printing is set to 0.4mm line width, and I have 3 walls. Also I will have the same printing with 0.6mm line width and 2 walls. This video and the whole channel is sponsored by Polymaker, and in this experiment I will use their new PLA Pro filament in red color. I have the review in the progress, testing 5 different colors. Before the main testing, let's talk about one obvious advantage of using two 0.6mm lines, and that's the printing time. With 0.6mm line width and 2 walls, the printing time is 1 hour and 18 minutes. And if I set everything to 0.4mm and 3 walls, the time is 1 hour and 24 minutes. Of course, it is longer, but I thought the difference will be bigger. We have 2 main limitations here. One is the speed because of that minimal layer printing time. And the second is the maximal flow, which is also limited. So with 0.6mm, it has to slow down to have the same flow. A few seconds of the printing. As you can see, there is no infill inside, but the printing can be finished because the top layers will be printed with the bridging. Side by side 2 dimensions, you can see different speeds because the layer printing time is same, 8 seconds in this case. All objects are printed, and outside visually there is no difference between them because I use 0.2mm layer height and there are no small details on them. I will measure their weight now. Now let's analyze this. The mass is very similar. Now these 2 groups are printed in vertical position, and this is the average from 3. These 2 are the most important groups, and exactly these 2 objects are heavier a little bit if printed with 2 walls and 0.6mm line width. I think the main reason for this is that we have less gaps compared to printing with 3 walls. Let's talk about one obvious disadvantage using 0.6mm line, and those are details. A great example is some text on horizontal surface. Now I noticed even the covering layer is nicer with 0.4mm line, but let's analyze the details. For example, letter E. Here with 0.6mm line, it is hardly readable. I think we even lost here horizontal line, and it is much nicer, completely readable with 0.4mm line. It's time to start the testing. This one is printed with 3 walls, 0.4mm line width. Aligning so it is in the center. And this is real-time speed. You can see here the current force in newtons and also the maxima, which is 278.4 in this case. And when the force drops to the half of the maximum, it automatically stops the testing. The next one is very similar. This is with 0.6mm, so this is speed up 4 times. Later I will show you the results on the graph. This is printed in vertical position. It breaks more suddenly. Real-time speed. And the results from 3 measurings. And this is printed with 0.6 mm line width. Also it will break very suddenly. And it was an interesting game. This is slow motion footage. I tried to catch the flying objects. And the results from 3 measurings. Hook test side by side, 2 objects. Very similar behavior. The maximal force is slightly different, but I will show it later on the graph. Starting with the tensile test, these are printed in horizontal position. Side by side two results, approximately 125 kilograms. Printed in vertical position, it will also break very suddenly. And the results for first 3.4 and 4.6 millimeters. Instead of creep test, I decided to do the bending test with this test object where the XY strength is more important. This is speed up footage, similar behavior between two objects, and side by side two results, no big difference. And the numbers presented exactly in the measured order. And with the yellow, this is the average from 3 measurings. And with the yellow, I mark those parts where the strength along the z-axis, or the layer adhesion, is very important. And I even calculated here the average value. And with the blue, in this case, these are mostly horizontal objects, and the strength along the x and y is more important. And as you can see, it is not always obvious that using these methods with 2 volts and 0.6 mm line width will make the part stronger. Sometimes actually it is even weaker, and here I calculated the average values. So yes, the method will improve the layer adhesion, but the effect along the x and y is unknown, but it looks like in this case the change is not significant. Looks like with this method we can improve the layer adhesion by approximately 20%. But if you need a strength along the x and y, then the improvement is not so obvious. Sometimes the part will be even weaker a little bit, but knowing that the printed part is anisotropic, this means the strength along the x and y is much bigger compared to the z strength, I don't really mind. And if on a mechanical part I don't have some small details, then I will use this method. And for the end, a friendly reminder, if you like this kind of videos, maybe you should consider subscribing and enabling that notification bell button. But I actually know that 80% of you who is watching this video already did that. Not sure why, but my videos are not really suggested to new viewers, only to those who enabled that notification bell button. Anyway, this is just a friendly reminder because most of my income is from the Patreon supporters, and that's independent from the number of the views. Only I'm always sad if some big work will stuck on quite low number of the views, really basically only to those who enabled that notification bell button. Anyway, thank you for watching this video until the end, and happy printing!